find the integral. And we're going to be using the substitution rule. The first step will be, of course, to determine what we're going to substitute, or what is u. In this case, I'm going to say that u is 2x squared minus 1. So u is equal to 2x squared minus 1. So now we're going to have to figure out the differential of u. What is that? Well, right below the u, we can write du. And over on the right-hand side of the equation here, we're going to need to take the derivative of whatever u is, which is 2x squared minus 1, with respect to x. Then we're going to write dx at the end. Okay, so what is the derivative of 2x squared? If you answered 4x, you are correct. If you answered anything else, you'd be wrong. So we're going to write 4x dx. Why is that again? Why is 4x the derivative of 2x squared? We just bring down the 2 and multiply by the 2. 2 times 2 is 4. We subtract 1 from the exponent, so we get x to the power of 1. And the derivative of negative 1, which is a constant, is just 0, so we don't bother with it. And of course, after the derivative, we must multiply it by dx. Okay. Now, what do? Well, let's just multiply both sides of the equation here by 1 over 4x. Okay? And this side, they're just going to disappear. Just like that. And what we can do now is that we can actually replace the dx that we have here for whatever dx is equal to over there. So dx is equal to this, 1 over 4x du. So I'm going to just replace it. So I have the integral, and now I have x over, I have the square root of u basically, right? I just replaced 2x squared minus 2x squared minus 1 for u. And over here, the dx is just 1 over 4x du. And why did I do this? Because now I can cancel out these x's. Look at that. They're gone. Great. So I'm just left with the 1 up top here, because x divided by x is just 1. And I can also remove this constant that is multiplying everything. So I can just write 1 over 4 times the integral. So we have 1 over the square root of u du. Okay, now what do? Now we can already take the integral. 1 over the square root of u, I'm just going to rewrite this as u to the power of negative 0.5. Or u to the power of negative half. Does that make good sense? I hope so. If not, please review exponent rules. Of course, because that's the same thing as 1 over u to the half, right? Half is just 0.5. If I want to bring it up top, I can just switch the signal of the exponent. So that's just u to the power of negative 0.5. Now, if we're taking the integral of this, what do we need to do? We just need to add 1 to the exponent. So negative half plus 1 is positive half. And we can divide, or sorry, we must. It's not only a matter of can. We must divide everything by 0.5. Whatever we have on the exponent goes down below as well for the integral. And we're adding a c, we're adding a constant outside, while we are still multiplying everything by a quarter. This quarter just comes down. Okay. Great. Now, what do we have? At this point, well, the 0.5 is just 1 over 2. Right? So that's just half. If I'm dividing something by half, I'm just multiplying by the reciprocal. In other words, I'm just multiplying the u to the power of 0.5 by 2. So I can just rewrite this as 2 root u. Does that make sense? I hope so. So we have 1/4 times 2 root u plus c. Now I can simplify this slightly. 2 divided by 4 is just half. So you get half times the square root of u plus c. And then finally, I can actually take what we had for u, which is 2x squared minus 1, and plug it in right there. So we have half times 2x squared minus 1 plus c. And this is our final answer. What we had to integrate is fully integrated right here. Hopefully that makes good sense. And I recommend you watch some more videos, which you can find right here. Good luck.